So here is a general. When we before we first start the training, can you please make sure that you are able to log in to the ProActive platform? So we will start to do a very simple workflow implementation and job execution. In the second step, we will explore how we can add variables and results to our workflow. In the third step, we will explore how we can add various kinds of scripts to existing tasks, which are pre, post, or clean scripts. In the fourth step, we will explore file transfer capabilities within ProActive. In the fifth step, we will explore control flow structures. The next section will be regarding how we can configure the environment for a workflow task. And notably through software container such as Docker or Singularity. And in the last step, we will explore meta-scheduling capabilities, notably the integration, the interaction with Slurm native scheduler. So I guess everyone is, well, most people are connected to the ProActive platform. So I will require you please to open the studio portal. So I'm going to do this. So let's log out, log in like this in the studio portal. And you should see something like that without all the workflows that I created here. So you should most likely have an empty list of workflows here and the create button. So what everyone is going to do is to click on the create button. This will create a new workflow called Untitled Workflow 1, which you need to open. And after you open your workflow, what I require you is in the general parameters name, enter a name for your workflow, which will be composed with training underscore your initial workflow. So after this is done, what you will need to do is from the task menu to drag and drop a task, either of these tasks which are supported by this environment. So you can drag and drop a shell task, a bash task, a Groovy, Python, Jython, JavaScript, Ruby, or R or Scala. So choose whatever task you prefer. For example, I will drag and drop the Python task. So you just open the task menu, choose one task, supported task. As I mentioned, for example, you cannot choose PowerShell or Windows here because we are running on Linux environment. We can not use Perl because Perl is not installed. So there are several tasks which you cannot use. The list of tasks that you can use is described here. Is it okay for everyone?
Mm-hmm.
Okay. So after this first task is added, What we are going to do is to add 2 other tasks. So similarly, you will drag other tasks. So for example, I'm going to add a shell task. I'm going to drag our task, and I'm going to put them like this, for example. And once I drag the 3 tasks in the panel, I'm going to connect them together. So in order to connect them, you need to put the mouse in the gray disk underneath the top task. You click on the left mouse button and you drag the arrow in the similar disk on the other task. So if you don't actually connect to this and you leave it here, that will create a new task. So if you do that, don't panic. You can go back. You can click on the task and hit the delete button to delete it. So if anyone has difficulties to do this operation, please let me know. So after this is done, I'm going to ask you to connect to the scheduler portal. To make sure that you are connected to the scheduler portal. Here, you can click eventually on this button here. And once this is done, you are going to use the play button to execute the workflow from the studio. So in the studio, you click on this button. This will execute the workflow. You will see a pop-up message showing that the workflow was submitted with a job ID. And here in the scheduler portal, you should see your execution. So if there are multiple users running at the same time and you cannot find your workflow, you can always check here on My Jobs to see only the job that you submitted yourself. Normally, I should not see any red here. This is because someone used a PowerShell task, which is not supported by this infrastructure. Okay, well, so several people have submitted a workflow. There we go. So now what we are going to do is to look at actually the output of this workflow. So in the scheduler portal, I'm going to click on my job, identified by the job ID here. I'm going to open the output panel. And after I open the output panel, I'm going to click on Finish Task Output to observe the output. So, okay, so we just took we took a random task, so the output, of course, will not be very meaningful, but it's just to demonstrate how we can submit workflows and look at a workflow. So if you want, you can click on each individual task. In the drop-down list here, you can choose selected task, and here you will see that the finished task output contains only the output of this task. This way, I can have the output of each individual task. So the shell task is only printing the content of the current directory. The Python task is writing the Python version and displaying a hello world message. And the R task is displaying a hello world message. Here we go. I see that most people have submitted workflow successfully. And now I'm going to show you how you can edit a workflow implementation. So in order to do that, you are going to select one task here in the studio, then open the task implementation panel, and you should see something like this appear. So depending on the task, you will have different implementation, each in the appropriate programming language. So suppose I select here the Python task. What I would like you to do, hopefully you choose one of these task languages and not and not a language which I don't explain here. But hopefully, so for example, for my Python task, what I want you to do is to copy this this code and replace it here inside the task implementation. So if you are not comfortable with this text area here, you can click on this button to open the full editor. As you can see, I made a mistake, so I'm going to correct it. So I'm going to show the operation for each task. For example, I'm going to write hello world in Python. I'm going to edit the shell task, open the editor, and do the same in shell. And do the same in our language. After this, I'm going to submit the workflow again. And observe the output. Some are doing already advanced example, I see. Okay. So in the next chapter, what we are going to see is how we can add variables to workflows and how we can define results of task and result of workflows. So in the first step, I will present workflow variables. So what we are going to do is to open, so in your workflow, what we are going to do is to click here in what we call a field area, to click here to go back to the workflow parameters, because when you are editing it, selecting a task here, you have the task parameter which are displayed. If you want to go back to the workflow parameters, you can either click on this link here, or you can click anywhere in the panel outside the task. Yeah. So when I click here, for example, these are the workflow parameters. So once you open the workflow parameters, you will open the workflow variables panel, which is this panel. So you click on it, and that opens the panel. And in the variables here, we are going to click on the Add button. This will pop up a model window. So when I click on the Add button, I have this window which opens, and I'm going to enter a name for my variable. So for example, I name it my var, and I give it a value. So I'm currently at this step here. So once I enter the variable, it should appear here in the list of workflow variables. Does everyone manage to do that?
Mm-hmm.
Okay. If someone is really behind, I'm going to be very, step by step. But if someone is really behind, please either, yeah, either in the chat or using your microphone, please tell me. So someone wrote in the chat, but I cannot see it. It's really difficult to. Galig has sometimes have. Yeah, all right. All right, this is very advanced. Okay. Okay, so now that we added a variable here to the workflow, what we are going to do is to display these variables in the workflow task. So what we are going to do is to write the following code depending on the language that you choose. So for me, I chose Bash, Python, R. So I'm going to copy, for example, this one in Bash. So Bash or shell is, of course, similar. So this time, I'm going to do that. So I've displayed the value of my var. I'm just adding Bash before here. Shell. Then I take the Python code. And I'm going to write this down. I'm not going to add another, yeah, I can do that, something like that. Probably simple. Button. Then I'm going to take the R code and write it in R. And then execute my workflow. Oh, there's a problem here.
I think you can refresh. Fabien?
Oui. Hello?
There are some people asking how to select the Python version inside the Python task.
All right. Yeah, so it's possible, but it's advanced. So if you really want to, so indeed there are two Python versions installed on the platform. One is Python 2 and the other is Python 3. But this is really advanced, and we are just at the moment doing beginner stuff. If you want, at the end of the session, I can explain you how to select the Python version, if you don't mind.
Can you share the syntax on the chat for the variables, please?
Sorry?
Can you share how to include the variables?
All right. So so to print the variable here, it's on the yeah. Sorry, I'm sorry. I thought that everyone has access to the slide, but it's not true.
No, it's not
yeah.
true.
So I think that's the problem.
Will you share the slide later?
Yeah,
or?
I'm going to do that because there are many copy paste. I completely forgot about this step. So normally, if you have access to the slide, you can go to the slide 8 and copy paste in the various languages that you use the instruction to print the value of the variable. So as you can see, depending on the language, the syntax to access the variable will be different. So now that I edit the individual task to display a variable, I can submit my workflow. And as you can see, when I submit my workflow, I'm able to enter a different value that the default value that I wrote in my workflow. So for example, I can write value 2 and execute my workflow. And once you have done this exercise, I'm going to talk about variables model. So variables model is a way to constrain a variable value. Okay, so if we don't give a model, we can basically enter any character string value inside the variable. But when we use model, we can restrict the data which is entered by the user according to the model that we choose. So in this example, in the workflow variable here that I created previously in my workflow, I'm going to click on the variable I create, and I'm going to add the model PA integer, which represents an integer. So if I do that, when I click on OK, it will say that is not correct because the model is an integer and the value does not represent an integer. So I'm going to change the value and put an integer instead. Okay, so did you manage to change the workflow variable and add in a pair integer?
How can I change the name of the variable? It is.
You can change the name of the variable here on the top. So if you want a second name, you can modify it here.
And how do I come to this? Python task. I don't have it. So this is Thomas. I don't come to the point to enter the PR integer. I don't know where to find this field. So.
Okay. All right. So let's go back here. So in the workflow parameters, you are in the workflow parameters.
Yeah.
Okay. Then you go to workflow variables. So did you already enter a variable here?
Yes, I think workflow. Right. Yeah.
Okay. Then you click here, and this opens this model window.
Stupid. Okay. Now I'm here.
Okay. Okay. So previously you should have something like value.
Yeah.
So what I need you to do is to enter a number here, and then to add PA integer. Once you've done this, you can submit the workflow, and you can see that, okay, the model here has been added. And if you try to enter something which is not an integer, let's say a float number, when I execute it, it complains that it's not correct.
Okay.
So it's a way to constrain, basically, the variables. You can always click on check to make sure that what you enter here is valid or not before you execute. All right.
I'm with you.
Everyone should have managed to reach this point. So this was the variable model. In the next point, we are going to talk about task variables. So previously, we talked about workflow variables. Now we are going to talk about task variables. So task variables are really similar to workflow variables. Instead, the difference with workflow variables is the scope. So for workflow variables, a workflow variable will be visible in the whole workflow, but a task variable will be visible in a single task. So if I click here on the Python task, if I go to general parameters, here we can see task variables. So what I'm going to do is to add a variable and call it with, for example, a different name and give it a value. So here I chose a different name, but it's possible as well to use the same name, in which case the task variable will locally override the workflow variable. And when I do that, what I do next is to modify the task implementation to display this variable. So what I've done here is the content of this slide. Task variable, general parameters, go to task variables, click on the add button, enter a variable name and value, then edit the task implementation. That's bad. Then edit the task implementation of this task. I think, yeah. And then run the workflow. Fine. So in the Python task, which I modified, when I run the workflow, I can see basically the workflow variable, which is 12 here, and the task variable, which is value 2. When we submit the workflow from the studio, we have as well the capability to change the value of a task variable by opening this tree list here, go to the task, and change the value of the task variable. So is that clear for everyone?
Mm-hmm.
Okay. So next step is the notion of propagated variables. So far we have done, basically we have created some variables statically inside the workflow, either at the, what we call the job level, at the level of the workflow itself, or inside a task. So what I'm going to explain now is that we can dynamically inside a task define a variable and propagate its definition to children tasks. So in order to do that, so you need to make sure that, all right, so we are going to create a new workflow now to illustrate this. So what I'm going to do here is to delete my beautiful workflow. So I go to edit and I do clear, that erase everything. I name it again, I give it again a job name, a workflow name. And what I'm going to do is to drag and drop two Python tasks. So drag and drop the first task and drag and drop the second task. I put them like this and I could connect them together. I missed. So you should have two tasks like this. All right. So once you have created the two tasks, you are going to edit the implementation first of the parent task. So you just copy this code, click on the parent task, go to task implementation, open the editor, delete everything, and paste that. So what I'm doing here is I define a variable here, which is not part of my workflow, which has not been defined on the web portal. I'm just going to define it directly inside the script. Similar, and in the second task, the child task, I'm basically going to copy, to print this variable that I defined dynamically. So I click on the second task, open the editor, delete everything, print this code, copy, paste this code, and save. Finally, I execute my workflow. As you can see here, it did not ask me to enter any variables because I did not define variables in the workflow itself. And when I run this, and when I observe the output of the second task, I see here that the variable that I defined on the first task has been propagated to the second task. So this is variable propagation. It propagates only according to the line of dependencies. It does not propagate in other parts of the workflow. So suppose that I create a third Python task and I try to print the same variable here. When I run this, in the third Python task which I created, I don't see anything. Thomas, I think inside the code there is some strange character which is not understood.
Maybe from copy and paste.
Yeah, copy and paste. This is typical, for example, when I write the slide, if I don't take care, I have a bad double quote here. So doing syntax error is very common. It's very common when we write workflows, of course. So in order to understand what's wrong, generally you need to look at the output and look at the errors displayed. So usually you will see a big Java exception, which is probably difficult to read, but in general you will see the error at the top of the output.
Line 9.
Still the same character. Thomas, so that's the second task you are having a problem with.
The second one.
Yeah, it's a Python task 2. So
and he refers to line 9, whereas my script is just one line. So
yeah, but I suppose there is something hidden. So just open the editor.
Yeah.
And select everything, and delete something like that, and repaste it. because you need to make sure here that you don't have something. That's okay. Great. So I will go to the to the next section. So we have seen that we are able to create variables dynamically in one task and propagate its value to a second task. And now what we are going to look at is what I call here system variables. System variables are variables which are defined automatically by ProActive, which are not user variable, but which are basically ProActive kind of variable. So in the child task of my workflow here in the Python task 2, or whatever is the child task, what I'm going to do is to add the following lines. So just basically copy paste these lines. And run your workflow. Then you can look at the output of your second task. And here you will see that these variables have been automatically replaced by ProActive. So the first variable, PA user, contains the username. The second variable, PA job name, contains the workflow name. The third variable, PA job ID, here contains basically the job ID, as we can see here in the scheduler portal. The fourth variable, PA task name, contains the name of the task which is currently executing. And finally, PA task ID contains the task ID, as you can see here. So these system variables, they really allow to basically sometimes, very often you won't need them, but sometimes they can provide useful. All right, so next section, it's okay for everyone regarding the system variables.
Mm-hmm.
All right. All right, so now we are going to look at task and job results. So what I'm going to do is to edit the first task here, Python task 1, and write the following code, result equal my result. Then edit the child task and write the second code. So basically, in the first task, I just defined the result of this task by affecting to the result keyword. I'm just saying, okay, the result of this task will be this. In the second task, what I do is I look at the result of my parent. So to explain a bit this expression here, to explain a bit this expression. The result with S keyword here contain the result of all parent tasks of the current task. The 0 here is the index among all the parents of this task is the index of the parent. So generally in the workflow, it's from left to right. So the value method here is basically is a method called on the result placeholder here to get the actual value. So you need to know that when you type only this result 0, it will contain a placeholder object which will contain various aspects of the parent task execution. So it contains, for example, the parent task log output. It contains if the parent task had an error or not. So if I want to access the real value of the result, I call here this value method on this placeholder. So when I run this this workflow, in the second task, I will be able to see my result. So it's very similar to the previous exercise where we were doing propagated variable. But propagated variable is the idea that the variable will be propagated to the next task, then to the child task, and to the branch children task as well. The result will is only an interaction between one task and its direct child or children if there are several. So if I write, for example, the third task here, this third task will not be able to see the result of the grandparent task. Only this one will be able to see it. Is that clear for everyone, the results?
No, it's not clear for me.
Okay. So what should I clarify?
Fabien, I think there is a question from Zinshin. It says, is result reserved word?
Sur mon truc. I'm confused between result and results.
I understand that you're confused.
Because
It's
in
normal.
the
All right.
parent task, it's result without S.
Exactly.
And
in the second task is results with an S.
task, it's results. So
That's
is
right.
it just a coincidence or?
Sorry? So to explain, these are two keywords.
Ouais.
Okay, so we've
Ouais,
seen previously that there are other keywords. So result and result with S are two keywords used by ProActive. Okay, and here in the parent task is going to define its result, and the result of a task is singular, like it's it's just writing a result output. So a task can have a single result, and in this single result, it can have a complex object, but the result of the task is singular. Now, the second task can have a result coming from multiple other tasks. So if I add, for example, a third task here and I connect them together, this task is able to see result from these two task. And this is why in this task, if you want to access the results of the parent task, we use a different keyword, which is result with S. Basically, it's an array. It's an array of objects where the index of the array correspond to the parent index in the workflow. So in here, this one will receive index 0, and this one will receive index 1. Okay, so what I showed just now here is the ability to basically to define the result of a task and to use this result in the child task. When I execute this in the scheduler to the scheduler, I can, for example, here in my task, I printed in my workflow, I printed the value of the result. But what I can do here as well is to click on the parent task, go to task preview, and then click on open in browser to see the result of this task. So okay. So what I'm going to do next is to assign a result globally to the workflow. So in order to do that, I will click on my parent task. I will go to general parameters, and then I will check task result added to job result. It means that the result of this task will be considered globally as a workflow result. So I'm going to execute this. So once I execute this, if I go to here to job results, I see here the task which I defined as a job result appearing here. And if I click open in browser, I am able to see it. And finally, if I go to automation dashboard, in workflow automation, remember that we saw this portal yesterday. So if I go to past job execution, my last job here, you can see that all the previous execution did not show anything here in the result list column. But once I added this this specific task as job result, I can see it here. And I can click on this button to open the result. Is that clear for everyone, how to define a result on one task?
No. What did you click or on the? Can you go back?
Sure. On which portal? The scheduler or automation?
Yeah, on the workflow. I think you.
Yeah, I was a bit fast. Sorry.
Yeah.
So I click on the parent task.
Yeah.
And then here in general parameter, I check task result added to job result.
Okay.
Fabien, maybe show a job with a list of results so the people can see how to get several results and access it in the portals.
So you want me to have several task results? Okay, can do that. So if I do here, so add another task. and this other task, I go to general parameters, I check task result added to job results, I execute this. And here in job result, now I see two tasks appearing. And similarly in automation dashboard, in the result list, now I need to select which task I want to see, for example, this one, and then I can open the browser. All right. So is it okay for everyone, this part?
Mm-hmm.
Okay. So in the next section, I will talk about results metadata. So I will explain this with an example. So what you're going to do is to create a new workflow. You can eventually, I don't know, sorry. I don't know if you should delete this one because it's used after. No, you can delete this one. So you can clear this workflow, and then from basic example, if I manage to open it. So in basic example, what I'm going to do, so you open the basic example palette, and then you go all the way down to result metadata, and you drag and drop this result metadata. So this template workflow is composed of two tasks, which will do basically each a similar thing. I'm going to first run this workflow so you can see visually what it does, and then try to explain. So just submit the workflow. There we go. And you remember that we can have access by clicking here on the scheduler portal, clicking on the task preview, and here you can see normally each task result. So if I click on this task and I do open in browser, I see here now an image. If I click on another task, the other PDF task, I see a PDF loaded. So the results of the workflows I submitted earlier, as you can see, Python tasks were textual results. Here, in this workflow I submitted, that we see that the result can actually contain real files. And these files can be displayed in the browser. So basically, how does that work? This works by basically this general idea. So what this task is doing, for example, is download image task. First, it's downloading from an internet some image. All right, and this image is represented here. This image downloaded locally as a JPG file, represented here using this instruction. What we do is we affect to the result the binary content of this file. So instead of result being just some textual output, it's really a binary content. And then what we do is we use the result metadata, which is another keyword from ProActive, which associate with the results a file extension and a content type. So here we know that this result, which is simply an array of bytes, the content associated with it is a JPEG image, and it's a JPG extension. Similarly, for the download PDF task, we download from an internet some PDF file. We materialize here in Groovy this file using the file API. Using the file API, we retrieve the binary content as a byte array, and we associate the two metadatas, basically the file name and the content type PDF. So what happens here when I submit, when the portal, when the task is executed by the scheduler and the portal, and we ask to the portal, show me a preview of this result, the portal understands that the content type is JPG or the content type is PDF, and the portal is able to display this content. We can as well use save as file here to save the image locally or to save the PDF file locally. So if you can try to execute the basic example and observe on your browser that it works. So similarly, as a previous example, what I can do, for example, is to click on the download PDF task and check task result added to job results, execute this workflow. And here I will see my download PDF task appearing in the job result. And similarly, in the automation dashboard, I can see here my download PDF task appearing, and this allows me to open the file content in the browser bar. Is that clear for everyone? So, of course, you don't necessarily need to understand explicitly what this code is doing, but just the principle. The fact that we affect to a result a binary content, which is a byte array, and we associate to result metadata the content type and the file extension. I mean, we don't need to associate the file extension, we can associate only the content type, or the opposite. So do you have any questions regarding what we call here results metadata? Okay, no questions. So I will go to the last part of this chapter, which concerns variables and results, which is the result map. That's another key word. So as you could see previously, when we were writing some task and results, we see that a task gives a single result. And when we need to put this result as a workflow, as a global workflow result, well, we will have the result of a single task. But sometimes you want to aggregate results from various tasks in a single view. And the way to do that is to use result map. So what I'm going to do is to create basically a new workflow containing 3 tasks. So I'm going to clear that, and I'm going to create a Python task, a Groovy task, and an R task. So Python, Groovy, and in the Python task, I'm going to write the following code. So result map, that's yet another keyword that we can use. And so this key, basically the result map is used a bit like the variables. It's a dictionary where you can create entries. So entries are materialized with keys and values. So I can, on a given task, I can add several entries if I want to. I don't need to add a single entry. But for this example, for each task enters a single entry for this example. So that was the Python task. I'm going to do the same for the Groovy task using the Groovy code here. So that will be entry 2. And finally, the same, I will do the same in our language. When I execute this workflow, result map. Here in job results, I will see appearing the content of the result map, which I put in each individual task. Similarly, it will appear in the automation dashboard. By clicking here on the result map column, I will be able to see the entries that I created. So this way, individual tasks of the workflow can contribute globally as a aggregated workflow result. All right. So now we are going to, so the training is supposed to finish at 12. And there are many slides still going on. So I will be a bit more quick on some parts here because we cannot go into details for everything. But I will still insist on the pre, post, and clean script. So far, we have been writing tasks. Each time we have been editing a task implementation and basically using a single language for a given task. But we have the possibility to add other scripts to a task. So I will demonstrate this by creating a new workflow. So we can add several additional scripts to a given task, namely the pre script, the post script, and the clean script. as the name suggests, the prescript is executed before the task main implementation script. So that's a task implementation script. And here I can add a prescript, which will be executed before, a postscript, which will be executed after if the task succeeds and does not fail, and the clean script, which be executed last, whether the tasks succeed or not. So in this example, I'm going just to choose a groovy task, and I'm going to add 3 scripts. So in order to add a prescript, I go to the pre-post clean script section after editing the task. I choose a language here from the drop-down list, and here I will select Bash, and I will simply write echo showing that I'm executing a prescript. I will do the same for the postscript. And finally, I will do the same for the clean script. You need to make sure here that the language is selected. If not, some error will appear. And finally, in my task implementation, I will write so as you can see here, the main script is in language Groovy, and the pre, post, and clean script are in language Bash. We can, using this various kind of script, combine multiple languages in a single task. So when I execute this, and I open the output of the workflow, I will see appearing.
So in the task, you mean to say you can do multiple languages to accomplish a particular task?
Exactly, yeah.
With help of Workflow Studio.
Yeah, using the Workflow Studio, you can combine multiple languages. The number of languages you can combine is not infinite. At most, you can combine 3 languages. 1 language in the task implementation, 1 language in the prescript, and 1 language in the postscript.
The third language, where do you combine? I couldn't get it. In the prescript and?
The prescript, the task script here, which is accessible in the task implementation, and finally the postscript.
Okay.
The clean script is a bit particular in the sense that it does not exactly belong to the task. I will explain why after. All right, and the clean script is really, as the name suggests, normally it's used only for, to clean up some environments, like some temporary files that you created or something like that. So when I run this workflow here, I see the output of the prescript appear, the output of the main script appear, the output of the postscript appear, but I don't see the output of the clean script. And this is because the clean script is particular. It's run after the task is finished. This way, it does not appear in the task output. If you want to see the output of a clean script, you need to click on server logs, fetch logs, and in the very bottom here, you will see the clean script execution and the output. All right, so I was quite fast for the pre, post, and clean script. Well, you can run this example whenever you have time. Do you have any question regarding this? Okay, so I will go on with the next chapter, which is file transfer. So in ProActive, we have internal capabilities to transfer files between tasks, or notably from the server to a task and from the task to the server. So we have a mechanism called data spaces, where we have predefined spaces. So two predefined spaces on the server and two predefined spaces locally to the task execution inside the ProActive node. So what we can do so the ProActive, so the predefined spaces on the server are called the user space and the global space. The global space is a file space public for every users of the ProActive platform, and the user space is a file space which is private to a particular user. So from this user space or global space to the task execution, we can transfer input files, which can be stored either inside the task local space or inside the node cache space. The local space is a temporary file, temporary folder, which is created dynamically for the task execution and which is wiped out when the task is finished. The cache space is stored, is a persistent space inside the ProActive node where files can be basically cached. That means if similar task needs to download files, download the same file over and over, they can use a cache space. In that case, at the first execution, it will transfer the file, and it will not transfer again the same file if the file did not change on the server. So from the ProActive server user space or global file global space, we can transfer input files to the task execution context. And from the task execution context, we can transfer output files to the user space or global space. To illustrate this, we are going to write an example which is available in the basic example palette. So I'm going to clear this workflow. I'm going to go to the basic examples, and I'm going to find the data management example. All right. So what this template does, so it creates basically here a file. It will transfer this file to the user space. That's the first task. The second task will transfer here any text file from the user space to the local space of the second task. And in the implementation, it will simply print the content of the file. So when I run this workflow, I can see in the job output that the content of the file was correctly read by the second task, which means the file is present. In the data management section, if I remove here this transfer from the server to the task, that will produce an error. This is because there was no transfer directive from the user space to the task local space to allow accessing the file. So I suggest that you try to run this data management template yourself. Do you have any question regarding this data space file transfer mechanism? I cannot go into details because there are many things to basically that I could explain about data space. The fact that we can use patterns here. There are many aspects, but we just don't have time to go in details into on this subject. So do you have any question regarding data space, the way it works, etc., etc.?
Do you have manual which we can read through?
There is a documentation, yes. Here you have in help, you can access the documentation where you can see various aspects. And for example, here, there is some documentation about data space. Any other question? All right. So I will go to the next item. So in the previous example, what we did is that we use here the data management template, which creates a file directly inside the task, which is done by this code. Transfer it to the user space and read it back on the second task. So in the second template example, we are going to demonstrate file upload mechanism. So this gives the user the possibility to provide as a workflow parameter a file which is either already present on the user or global space or locally on the user computer. So I'm going to clear this workflow. I'm going to go to basic example and then drag and drop the file upload template. All right. So this file upload template contains two tasks. So each task will transfer a file from either the user space or the global space. And the particularity of this template is in workflow variables, we see two variables appearing with a specific model. Here we see a model PA user file, and this model materializes a file which needs to be present on the user space. The other workflow variable here use the model PA global file, which materializes a file which needs to be present in the global space. In each individual task data management section, we can see here that the variables are used directly in the includes pattern here. So when I submit this workflow, if I try to submit it like this, it will say, oh, I need to give a value to this input file from user space or input file from global space. It says, please provide valid path in the user space as a variable value. All right. So I could even, if I want, type a path directly here, but I can click here in the browse button to be able to select a file from the user space. I'm going to demonstrate that we can, using this dialog window, I can eventually create a folder. Double click on this folder, on the folder to go inside, and I can upload a file. For example, I'm going to choose this one. an image. I upload this file and then I can select it. I do select, and here I see that this value has been now filled. I can do the same for the global file. Here I'm not going to, so it takes a while to load. So here I'm not going to upload because there are many files in the global space already, so I don't need to do it. I'm going simply to choose one file. Let's say this one. There we go. No, this one. An image. And now, if I do check, it says that now the workflow is valid, and now I can execute. So it has been run. So the result of this workflow is very similar to the metadata. It's just a demo on this workflow, and basically it shows in the task preview the file that I have selected. There we go. But it shows that you can give a file parameter to a workflow using the variables PI user file and PI global file model. So I invite you to run this file upload template yourself and to test it if you can do it. All right. Okay, so that was the file upload. I invite you to test it basically simply by executing the template. And in the meantime, I will explain the control flow structure. Control flow is an important part of proactive workflows so instead of writing statically, adding tasks to the workflow like that, with control flow structure, you are able to really add dynamicity into the workflow execution. So we have three types of control flow structures. We have the branch, which is similar to a if-else construction. We have a loop, which is similar to, of course, to iteration. And we have the replicate, which is similar to parallel executions. So these are the graphical representation of the three control flow structures. So if, else, loop, and replication. We can have control flow structures which are doing operation or on single task or on multiple tasks. So here, this if control flow structure is operating in the if or else on a single task. Similarly, the loop is looping on a single task. And on the right, the replicate is replicating a single task. But we can have as well multiple task structures. For example, the left one here, if has more than one task in each if or else branch. The second one here, loop, has is iterating over more than one task. And the last one, replication, is replicating not a single task, but a couple of, but here in this example, 2 tasks. Here, I present only 2 tasks, but of course, you can have more than 2 tasks. You can write, hierarchy of tasks inside what we call control flow blocks. So I will start the lesson with the branch control flow. So in order to do that, what you need to do, so create a new workflow, go to the controls menu and drag and drop the if flow control. So this will appear. After you do this, what you need to do is to add a workflow variables named branch selection with the value if and the model explained here. So I will do this operation. I'm sorry if I go a bit fast because there are still a lot to cover, and well, we need to do it. So in the workflow variable, I'm adding this variable, branch selection. In the value, I put if, and in the model, I put this without the dot, be careful. Right. So you can see that when after I add this variable, when I submit, it proposes here branch selection. All right, but that's not the only thing I need to do. So I need to click on the if script. So I click here on the if script, and I'm going to replace the if script content with the following code. So what I'm doing is I'm simply using the variable to select the branch of the if. So if the variable contains if, I will go here. And if the variable contains else, I will go here. Finally, in the task implementation, I'm simply going to click on the if task and replace the following code. And in the else task, I click on it and I replace the following code. All right. So now when I run this workflow, again, I see my branch selection variable. I execute it first. And we can see that here, either in the visualization or in the task list, that the if task was executed and that the else task was skipped. You can see it has got here. If task was executed, else task was skipped. If I run again and I change the selection, now I see that the else task was executed and the if task was skipped. So here we control the branch using a variable which is basically statically determined at workflow execution time. But we can do much more dynamic type of decisions. Inside the workflow, in the if script, you can, for example, reuse the result of this task to dynamically decide whether you should run branch or another one. You don't have to use a variable for that. It was just for to simplify the example. All right, so I invite you to do this if. Wait 1 minute to let you a bit of time. So I will go on with the loop control flow. So while I'm talking, if you want, you can try to write the if workflow. So similarly to the previous example, what I'm going to do is to clear my workflow, to go to the controls menu and drag and drop the loop task. I'm going to add variables here. A variable. Similarly to the if. So a variable called iterations with value 4 and with model PA integer. So that will be the number of iterations of this loop. I'm going to click then on the loop script and replace its content with the code presented in the slide. So to understand this, here is the variable I entered in the workflow. The variable provided to the workflow is a text variable. So in order to be used in programming language as an integer type of variable, I need to convert this variable to integer. And what I'm doing here is that, so this script is run to decide whether the loop should continue or not. So here, this expression says, if the current iteration index is lower than the maximum number of iterations we want to run, then I continue. If it's bigger or equal, I stop. So I can, when I submit the workflow, I can change here iteration value. And we can see here that the iteration was run 3 times. So 3 times, it means that I made a mistake in my test. I should, instead of doing this, I should -1 the number of iterations. So now I run 2. And here I see 2 iterations. So as you can see, this basically this workflow is composed of 2 tasks. On the first iteration, it ran the 2 tasks, start and loop. It ran the loop control flow script, and then it decides whether it should loop again. So the first time it decides it can loop, and then it creates 2 new tasks named accordingly to the original task and adding a specific pattern index. If I now use 4 iterations, we can see here that the number of tasks being produced increase. And finally, so I have to go a bit fast. So this variable that we see in the code we wrote here, PA task iteration, is another example of what I called in the previous slides system variable, which is a variable which is automatically set by ProActive before executing the task. And this variable contains the current iteration index, starting from 0, then 1, then 2. All right. So this one, I guess, is a bit complicated. So while I'm explaining this one, I invite you to try to run the if workflow for those who are still at the if or the loop. And I'm going to do the replication example. So I'm going to clear my workflow. In the controls, I'm going to go to drag and drop the replicate example. And I'm going to define similarly replications workflow variable, value 4, model PA integer, and then I'm going to replace the content of each task with the following code. One, two, and 3. So when I run this, I can choose here the number of replication, let's suppose 10. And I submit the workflow. And here we can see that many tasks have been produced. And all tasks replicated here are being run in parallel. So in the contrary to the loop, you see that the loop execution contained 8 tasks, but it took 8 seconds. Here the replicate took much less time because all tasks in the process block were run in parallel. So just just to let you know, the code I wrote here is what we call the Euler algorithm to compute P. But of course, it managed to compute P after a very large number of iterations. In general, it's not very efficient. So here I can see that I have a very coarse approximation of pi. And yeah, so I could run with many more replication, but to make it very fast, I'm going to do here a simple modification, which I will explain later. Then when I submit my workflow, I will be able to use, let's say, 200. Sorry. I submit my workflow. As you can see, it's already finished. So it ran 200 tasks in parallel in 7 seconds. And now I can see that the approximation is a bit better. All right, so that was the explanation about replication. I didn't go much into details. So similarly into the, for the loop control flow, we have here a system variable called PA task replication, which contains the replication index. So the first, it will replicate the process task many times. The first task will contain replication index 0, second task index 1, etc., up to the number of replications. So to explain briefly what this task is, this replication here is doing. So in the split task, what we do is we construct an array which contains a set of number. So based on the total number of replications we choose, we create an array of double values, each containing a number according actually to the Euler series. In the process task, what we do is that we compute the square of this number. And in the merge task, we aggregate all process task results. So first, we compute the sum of all these results. And finally, we use this formula to try to figure out what is the value of the pi number. Do you have any questions regarding replication? No? Sure. No one has a question regarding replication, loop, or control flow?
I have one question, basic question maybe. So it's about how do you bundle them in the workflow? You will put it across or you will demonstrate that, or how do I put these all logics inside? these tasks into a workflow?
All the logic. You mean, yeah, you
Like
didn't.
you have you start writing a code, right? You have this,
Yeah.
you have to use control, you have to put input variables and all. So from the perspective, this workflow looks to me a replicate workflow, right?
Yeah,
Where you look
that
at
is.
it.
Yeah.
And but on top you have multiple things running on top, right? On the code perspective, not only replicate, but this is one task as per
Yeah.
me.
That's one task, exactly.
So how do you put multiple tasks together and make it a package kind of a thing?
You mean how to connect them together?
Yes, yes, yes.
Okay, so here what I did is I drag and drop the replicate control, which contains already the structure. Okay, it contains,
Okay.
and then I simply edit this already made template and just modify the code and add a variable. But what you can do as well is really create a control flow structure from scratch. So if you want,
Okay.
yeah, if you want, you can drag and drop a single task,
Right.
and here you can, if you need, you can go to control flow, replicate. All right, so I need first to do that. Here, drag and drop to replicate, add a merge, define a language, basically here. So I have the same structure. You can build it from scratch, but already to make it faster, I use already made template.
Okay. Understood. Understood.
Right.
Thank you.
You're welcome. Okay, so that's it for control flow structure. I will now talk about fork environments. So what is a fork environment? It's an isolated environment dedicated to a task execution. ProActive supports two kinds of fork environments. So to answer Denis, yes, I've shown the XML format of workflow. I shown that, I've demonstrated that yesterday, but I can demonstrate it again. So here you need to understand that whenever you write a workflow, the workflow is actually internally represented as XML. And if you want to see the XML representation, you can go to File, Export, and here you can see the XML representation of the workflow. You can download it on your computer, and you can do the reverse operation. Suppose that you have a workflow XML stored locally on your computer, you can use this button to import as a current workflow. All right, so I will now talk about fork environments. So when a task is run by default, it is run inside a dedicated Java virtual machine, which is started to execute the task. All right, so good actually to use here Linux/task. So if I go to the fork environment session, I see that this option fork is checked on by default. It means that this task will actually, in order to execute this task, ProActive will start a Java virtual machine, which will be used as a container of this task. And ProActive supports two kinds of fork environments. The standard Java virtual machine fork environment, which is the default mode, and additionally, the capability to run a Java virtual machine inside a software container, such as Docker, Singularity, or Podman. In that case, the Java process, the separate Java process, instead of running on the same environment as the ProActive node, will be run inside the software container. And ProActive can execute tasks without a fork environment. So that's the case where we uncheck fork. That's without a fork environment. That means without a dedicated Java virtual machine or with a fork environment. which is default. So to illustrate this concept, you have the non-fork mode in that case. So the non-fork mode is when I uncheck fork. And in that case, the task is run inside the ProActive node Java virtual machine. The fork mode, which is the default. So when fork here is selected, in that case, a dedicated Java virtual machine will be started and the task will be run inside this dedicated Java virtual machine. This allows, for example, this is mandatory to set environment variable, to have full control on the task execution. For example, if you want to interrupt brutally a task, the fork mode is highly recommended. And this is mandatory as well to be able, in the task implementation, to access, to create files and transfer them directly using the current folder. Okay, so it's in non-fork mode, it's possible to use transfer file as well, but in that case, in non-fork mode, you cannot directly use the current folder. You need to add a specific keyword to refer to what we call the local space. And finally, the fork mode with containers. So in that case, you can see that from the ProActive node, Docker or Singularity or Podman container is started, and inside this container, a dedicated Java virtual machine will be run, which will execute the task. All right, so let's demonstrate this by an example. So I create a new workflow, I add a bash task, which I've done already. And in this task, I will go to the fork environment session, and in environment variable, I will add a new environment variable. So I go to the fork environment session, I make sure fork is selected, and I go to environment variable, and I create an environment variable here. Inside the task, I'm going to display, I'm going to print out in task implementation the content of this variable. When I run this, it's not groovy anymore. I can see that this environment variable was correctly fetched by the task. Now, if I remove here the fork environment session mode, and I run again, so first I can observe that the task execution is much faster. And this is normal because we don't start a Java virtual machine to execute a task, so it's faster. And here I can see, unfortunately, that the environment variable I created is not accessible. I talked about the difference of task execution context, so I'm going to illustrate this by using the pwd variable command to print out the current folder. So when I run in fork mode, here is the content of the current path. You can see that it's really a temporary directory, and this temporary directory is what I called before the local space. Now, if I remove the fork mode, that's very different. That's the current folder. That's the current folder of the, yeah, it's the root of the system, of the file system. But in non-fork mode, it is still possible to access inside the task to the local space. In that case, I can write the following code. And here I find the local space again. So that's Java fork environment mode, and I'm going to talk now about the Docker fork environment. Do you have any questions regarding the Java fork environment mode? So there are many things you can personalize in the fork environment. You can change the Java home if you want to. You can add Java virtual machine arguments. For example, if you want to augment the number of memory available to the Java virtual machine, you can run the task in a specific working folder, etc., etc. You can add Java libraries to your task, environment variables, as we said. Okay, no question. So I will go on to explain now the containerized version of the fork environment. So again, using this task, the same workflow, I create a bash task. And in the fork environment session, in the drop-down list here, I'm going to choose Docker. So when I do that, what it does, it sets some setting here to Java home. And most importantly, it populates here what is called the environment script. So the environment script is a script executed to configure programmatically the environment of the task. And you can see that the script is quite big. And the purpose of this script is to eventually run commands and most importantly, use the fork environment API to give parameters to the task execution. All right. So in order to illustrate this example, I'm going to change here in the fork environment script the following line. So in order to do that, I open the fork environment script, and here in container name, I'm going to replace the default value with something else. So here I'm going to use a Ubuntu Docker container version 18.04. And in the task implementation, I'm going to write a statement to print out the current operating system. So when I run this, so it goes very fast. It's because the Docker container has been already built and downloaded, but normally it takes some time to download the Docker container. And if I run this, I can see here that I'm running on Ubuntu. Which is different from the node because the node is running on CentOS 7. So I can show that this task was actually run inside a Docker container on a specific environment. All right, so now I'm going to do exactly the same on Singularity. So I'm going to clear this workflow. I'm going to drag and drop the task. Click on the task. In fork environment, fork execution environment, I select Singularity. Then I open this code, and here I'm going to change this line. So I search for the line. It's a bit different, sorry. So it's not container name, it's image. Yeah. So when I run, I forgot to write the operating system. So similarly, I write instructions to display the operating system version. And I run it again. And again, we can see that I'm running inside this Singularity container in Singularity Ubuntu 18.04 container. Now, so this slide is basically, it's a clarification to explain that when we run proactive tasks inside container, we need to take care of what libraries are embedded in the container. So in proactive, in this environment, in order to be able to run Python or R tasks, we had to configure the system before. We had to install R, we had to install Python, we had to install a specific library that we use to interact with R, and similarly to Python. But if you use a random container, you have a chance that this random container will not have Python installed, will not have R installed, most likely will not have the library that we use. So you need to be careful that, of course, this library are correctly installed. So I will not go into the detail about this, which is because it's a bit complicated, but you can read what I wrote in here if you need to go further. I'm going to talk about now the fork environment script, basically the script context. So I explained that various kinds of scripts, so the task script, the pre-script, the post-script, are executed in a different context. So this diagram shows where the scripts are executed. So in non-fork mode, it's simple, all scripts are executed inside the proactive node Java virtual machine. Now in fork mode, you have the environment script, which is environment script, which is the script that we see here. So this script, of course, it's used to configure the dedicated Java virtual machine, so it needs to run on the proactive node directly. Similarly, the clean script, which is run after the task execution, is run directly on the proactive node. And all other scripts used by the task are run inside the dedicated JVM. Finally, we have a last bit of Docker integration is the ability to build Docker container. So this is completely different. It doesn't use the fork environment, but it's accessible in the task menu. So in the task menu, you can drag and drop the Dockerfile task. And the Dockerfile task is run similarly to a Groovy task or a Bash task. It basically just simply run a set of commands which is going to build and run a Docker container. So in this task implementation here, we see that we have a Dockerfile. And when we run this container, in the execution, we can see that the Dockerfile has been built, the image has been created, and then the Docker container has been run, and finally, at the end, the Docker container has been stopped, and the image has been removed. So it's a lightweight way to run Docker container on the fly, to build and run Docker containers on the fly. Do you have any questions regarding this fork environment and eventually the Dockerfile task?
Fabien, if you could check out the chat, there are some questions.
All right. There we go. So regarding the question from Jin Shin, you talk about the fork environment, or do you talk about here the Dockerfile task. Because for the fork environment, in that case, the image is not built. The image is downloaded.
Yes, but in the slide, I can see the JVM which is inside the container.
Yes.
Why is it inside the container?
It's inside the container because the dedicated Java virtual machine is a placeholder to run proactive tasks. You cannot run proactive tasks without a Java virtual machine. So this virtual machine is started inside the container to give basically to give to the proactive task the container as an environment. So where would you expect actually the dedicated Java virtual machine to run?
I don't know. That's why I don't see how the JVM, the dedicated JVM, is run inside the container.
Okay. Okay.
In the namespaces of the container.
Okay. It's actually, I think it's quite simple to understand. All right, so let's take an example of my Docker.
Because for me, the container is just instantiated from an image, which is, let's say, downloaded from the Docker registry.
That's right, yeah.
And it doesn't contain any Java code.
Yeah, it does not contain necessarily any Java virtual machine, not even a Java installation. You are totally correct. But in order to be able to, because we need to run Java, if not, we cannot run proactive tasks. So maybe it makes more sense if you read actually the output of the fork environment. So let's look at that. So this is the fork environment script. The goal of the fork environment script, which you see. So I'm going to clear that. I'm going to do, let's say, bash, click on it, fork environment, and choose Docker. So the goal of this fork environment script is to produce a Docker command which will actually run the Java virtual machine. And you can see here in the output of this execution, you can see that I produce a Docker command which does Docker run, and then plenty of parameters which are used to start the Java virtual machine. Among these parameters, you notably have mounting points here through volumes options, which basically mount the Java runtime environment, Java libraries.
Okay, I understand. So the Java code is actually on the host, and via mount, that's what you mean.
Exactly. Yeah.
Okay, I understand.
We transfer or make it visible from the container.
Yeah, and for Singularity, you also use a bind to mount the Singularity program. Oh, your Java program, I mean.
You can see it here, Singularity. So for Singularity, we pull the image first.
Yeah.
And we use bind similarly to expose the Java runtime environment and Java libraries. All right, and we mount as well the local space. I mean, it's all made to run with ProActive. So, for example, if you create a file using the data space and the local space inside the container, you are able to transfer this file from the container to the ProActive user space, etc., etc. Any other questions regarding containers? Maybe I missed some question, or did I answer to everyone? Okay.
There's still a question.
Sorry?
There's still questions.
All right. The image is not actually modified. No, the image is not modified by ProActive. The image is taken as it is, and we just add mounting points. That's the fork environment as well. Is it possible to run multiple tasks inside the same forked environment? No. No, it's not possible. One task, one fork environment. But you can run multiple instances of tasks, each with their own dedicated containers. Okay, and I need to do the last section. I talk about Singularity, Docker, and Docker file tasks. So the last bit, there are a few slides left, is the meta scheduling part. So in that sense, it adds new capabilities to Slurm execution. Because it's really able to translate ProActive workflows inside Slurm. And as for the people familiar with Slurm, in Slurm you can do several kinds of executions. You can run MPI tasks, you can do parallel batch, but whenever you need to run complex workflows, this is very difficult to do that with Slurm. Additionally, ProActive allows to aggregate computing resources from heterogeneous origins, what we call ProActive nodes, which is an abstraction of resources. And you can aggregate, for example, resources from a Slurm cluster. You can have resources, Windows machine, cloud instances, all shared in the same environment, all seen in the same environment. And with the ability to create a workflow and to run some part of the workflow on a Windows server, another part on Slurm cluster, etc., etc. This is not possible using Slurm. So the meta scheduling architecture of ProActive? How does it work? So you have all these various components. All right, so a lot of terms. So what you need to summarize, what you need to understand is on one bit, you have the ProActive scheduler queue, which will receive workflow tasks to be executed. This ProActive scheduler will query the ProActive resource manager to request dynamic deployment of ProActive nodes to execute this workflow task. The ProActive resource manager will run sbatch or sbatch command to start Slurm jobs to deploy the ProActive nodes. And similarly, scancel command to shut down the ProActive nodes. And inside the Slurm node, you will have a ProActive node running, which will execute the task which was originally in the scheduler queue. So it's a complex process which goes from the left to the right and back. So in order to run a ProActive task or ProActive workflow inside Slurm, this is controlled through two what we call generic information. A generic information is similar to a variable, is some information, it's a map, dictionary kind of structure. And in here, so the contrary to variables where you can create your own variable, call it as you want, generic information need to be named, have specific names for specific usage. So here we have two generic information in use. The first one, NS, which is a shortcut for native scheduler, is decided whether we should run a task or a workflow inside Slurm or not. So if it's present, it will decide to run on Slurm. or PBS or whatever you have. And if it's absent, it will not run on Slurm. And the second generic information called NS batch is a set of additional parameters that we give to Slurm to control the execution. So we are going to do a simple example. I'm going to write a set of tasks. Here. And in the workflow here, in the workflow generic information, I'm going to write NS Slurm. And we're going to see here what happens in the resource manager. So it's actually we see here 3 nodes appeared. So this error is something to fix for us. And here we see that the task, you have seen that the nodes appear yellow, orange, that illustrate that this task is executed. And right after, we saw that the node disappeared. This is because the tasks are terminated and the nodes are removed from the resource manager. So in here in the resource manager portal, when you click on the Slurm node source, you can see dynamically here the nodes, basically the jobs which are submitted to Slurm. So to illustrate this, I'm going to do a simple sleep, let's say 20 seconds. All right, so now we can see here the resource manager with the sleep. And here I can see in the queue my job. And again, so it was 1 minute. And again, after when the task is finished, the node is removed from Slurm. So you can experiment with Slurm execution to see to observe that it's transparent. I can do, let's say, again a replicate for maximum fun. And here, just make it as fast as possible. So as it's a replicate, it will run first the split task. And then after the split task is run, you can see that it add a lot of nodes to execute the individual workflow task. And now it runs them all. And finally, it waits for the last task, the merge. Then the workflow is finished. All right, so using the NS batch, you can add extra parameters to Slurm. For example, you can control where for example, the partition used to execute proactive workflow task. So by default, it's using the partition containing GPU machine, but we can use instead the CPU machine to reduce a bit the number of tasks. And as was displayed before, we saw GPU 01, GPU 03 machine. Now we see CN01 and CN02, which are compute CPU machines. And we can add all type of parameters which are supported by Slurm. In the last example, I'm going to show that okay. So in order to illustrate that actually nodes are tasks are being executing in Slurm, I'm going to do some sleep. 60 seconds, sleep 1 minute, and here. Now we see that these 10 tasks can run in parallel with a sleep of 1 minute. We can see that they appear here all busy.
Great, Fabien. I think we have a question from Rémi.
All right. Okay. It seems okay. Yeah, very good question. Yes, for this training, we configure the Slurm infrastructure to execute all tasks with a single user. But it's of course possible to match proactive users here with how tasks are being executed inside Slurm. So exactly what you say, yes, it's totally possible. Just I'm going to show you. Okay, I'm going to show you this setting. So this is the configuration of the Slurm infrastructure. So I'm going to, well, just do that to show you the parameters. So we have many, many parameters. Sorry, we have many, many parameters. And here, regarding what we use is a single connection username mode and with a single account username and password. And this is used when the impersonation method is none. But we have 3 types of impersonation. We can use sudo or we can use SSH. In that case, when we use SSH, the proactive account login and password must match the account on Slurm, and it will use SSH to basically to first create a SSH session and then submit to Slurm using the dedicated account. Does that answer your question, Rémi?
Fabien, actually, tell me if we can say that, but I guess the Slurm user are coming from an LDAP, and the Activeeon ProActive user we will be coming from the same LDAP, right?
Exactly. We can configure ProActive scheduler accounts
so
using LDAP.
It's not even a mapping. It's actually the exact same user within ProActive and within Slurm for the entire IDRIS infrastructure.
Yeah, yes, it's not it's translation. It's the same account. Yeah, if the accounts are defined using the same source, which is LDAP, of course they will match each other.
Does that answer the question, Rémi? One small thing, Fabien, can you comment on my note? Because I guess in the case of Jean-Zé machine, there will be execution only on Slurm. So in that case, we configure the installation so that the user might not even have to add generic information to explicitly request to execute on the Slurm cluster. It will be by default.
Yeah, it's possible to do that, but the user will have eventually to use the NS batch generic information to give additional parameters to Slurm, but it will not be necessary each time to provide this generic information.
So there can be like a queue by default where people execute when they don't ask any specific resources?
Yes, this can be configured here in the Slurm infrastructure, because here we control the command which is given to sbatch, and we can even add a dedicated, by default, a specific queue. But in that case, you need to be careful, because if you use nsbatch, well, you can have conflicts. So just you need to be a bit careful. But in general, Slurm, when you submit an execution, it puts it in a default queue. This is the normal way of working. But if you want, for example, that all proactive jobs goes in a specific queue or partition, you can add this directly here to the to the NS submit command, and all proactive workflows will be there.
Okay. And actually, we can also configure with several Slurm node sources, right?
And as well, we can have multiple Slurm node sources. That's right. In that case, you can use here the NS generic information to choose one Slurm node source or the other one.
You have also the possibility to lock the node source nodes.
So we cannot hear you very well, Mohammed.
I just said that there is the possibility to lock the node sources that we don't want to run the jobs. So that we keep only Slurm, for example.
Okay, so the last bit is an example using MPI Hello World. So what I'm going to do is here to clear my workflow, and in basic example, I'm going to go all the way down to MPI Slurm, and this is an example of running some MPI code on Slurm. So this task is composed of 3 parts. There is a prescript here, which contains some C code, which is hello world in MPI. This prescript in C will be written as a C file, a C source file. In the task implementation, what I do is I'm going to load the MPI environment and copy my source code in a dedicated folder and compile this source code into an executable, and then run this executable as using MPI run. Finally, there is a clean script which there is a clean script which clean up the environment and the temporary folder. In the workflow generic information here, I have my NS Slurm generic information, and I have this NS batch parameter, which is using a workflow variable. When I submit this workflow here, I can provide Slurm parameters, and notably these parameters which controls the number of nodes allocated by Slurm to execute this Slurm job. So if I use the default here 10, when I run it, so it produces a task, a node. And here in the execution, I can see that actually some MPI code have been run on several cores of Slurm. So it's a single task from a ProActive point of view, and it's a multi-node execution from the Slurm point of view using MPI communications. I can increase the number of nodes, let's say 100. And here we can see that it runs even on multiple machines, individual MPI executions. So that's an example of how you can embed some MPI code inside your ProActive workflows. And the interesting aspect is that you can have some MPI tasks, and then in ProActive you can do some post-processing, adding other type of tasks, etc. Or, for example, iteration of APIs, of MPI code, for all kind of iteration algorithms, etc. So do you have any questions in general regarding the Slurm integration and what I presented here? Just need to look at the conversation because not everyone can use the microphone.
Fabien, just at this stage, we have seen a very powerful tool with a lot of possible configuration. I just wanted to remind the participant that the goal about all the feature in the workflow building is to be able to have expert people or people which are there to assist the end user to build the workflows which are ready to be used by non-IT specialists. For instance, if you go to the catalog, Fabien, you can show the CFD go in automation dashboard, yes, and go to the CFD bucket, which are example, so it's fluid dynamic, yes. So these are a set of workflows ready to be used by end users. So end users do not need to see the complexity of setting up parameter and setting up, for instance, visualization. So there are workflows with graphical visualization with power views, and all this can be packaged and ready to be used just with a few parameters for the end user to fill up.
Well, Denis, I'm sorry to correct you, but they are not exactly ready to be used, these workflows.
No, I'm not saying it's
And it's
reduced
the
because
idea. I get it's the idea,
those needs a labs server. So of course you cannot use them right away here, but the idea is to build workflows with the right access to licenses if there are some license to be used, and then to have the end user using just filling up parameters.
Yeah. Okay, I need to do the conclusion because I have a call, another call starting at 1 p.m. So I cannot stay more. So I'm just going to do the summary of this training. So what the key elements of what we've seen today is how to write simple workflows in different languages and monitor the execution using the ProActive portals. How to add parameters to workflows using workflow variables, how to propagate results from one task to another inside the workflow, how to define workflow global result through the result map or adding a specific task result to the job result, how to use various kind of scripts inside tasks, remind you the pre-script, the post-script, the clean script, etc., etc. How to transfer files between tasks using ProActive data spaces. Of course, you can use ProActive data space to transfer files, but you can use any native command lines such as or protocols such as SCP or rsync if you don't want to use a data space. It's not mandatory to use data space. How to I present as well how to upload files as workflow parameters. And how to use control for structure, how to control the task environment with or without software containers such as Docker or Singularity, and how to execute transparently workflows inside a Slurm cluster. So that's my final conclusion. Do you have any final question?
So just a quick reminder. So we are looking at mapping the user space directly to the to the share file system available on the Janze machine. So this is something that we are looking at for the future. So people will be able to directly upload and download file from the portal, mapping to the usual file system. Have you shown yesterday or today, Fabien, the capacity to upload and download files for workflow automation?
Well, I showed on the studio only. I focused on the studio, but no, I didn't present the workflow automation portal ability. Basically, you can access here and manage files. You can do manage global space files to open the global space content, which allows to upload a file, download a file, create a new folder, etc. And you can do similarly manage user space files here. All right. So I think that's the end of on this training session, which was quite long.